Hello, today I want to tell you how to work in DTX tools. This program is designed to check the values at the inputs and outputs of controllers. In fact, it serves for debugging. To start the program, you must first connect the controller DTX and DT-USB to the power line and the communication line. Turn on the power of 12 volts and connect the DT-USB controller via the USB cable to the computer. Then run the DTX tools program. When the program starts, you must select the COM port in the program and press the Open key. When we get to a controller, we have to do Get ID. This indicates that there is a controller in the system. Then select the address of the controller. For instance, is the controller number 1. If you have multiple controllers in the system, you have to select the address of the desired controller. I do the function getID. We have determined the firmware of the controller, so we have a connection with the controller. So how to check the output and input signals? The output signals are the light bulbs connected here. They characterize the load of 12 volts. Further, to check if they work, you have to press the button corresponding to the output. Output number 1 gives 12 volts. Output number 2, 3, 4, and so forth. Similarly, the power can be removed from them. The outputs are checked. Now we get to the sensors. The sensors are connected to the input group. There are 3 types of sensors: discrete, analog, and RFID. The first input of the controller, a photoresistor, is connected to it. I will check the photoresistor with an analog signal. So I take from it the value of getADC. When the photoresistor receives light, the value is minimal, 2 or 3. When I cover it from the light, the value increases. So we check the illumination of the resistor. When there is a light, it is minimal. When it's dark, it's maximum. Similarly, I can interrogate the sensor in the form of a discrete signal. To do this, use getInU. When there is a light, it is 1. When there is no light, it is 0. For the values to be more or less stable, you need to use this command several times. The second connected sensor is the read switch. On its place there can be a button or just 2 wires that can be closed. I press the function getInU. There is a 0, no closure. As soon as I place the magnet here, the closure appears, there's 1. Next connected sensor is a microphone, the usual microphone from Arduino. Since this microphone needs power, I'm using the input number 4 to give this power. On the controller, the inputs can supply 3.3 volts. This is enough for an Arduino sensor. I'm giving power to the input number 4. The power has appeared. You see the light bulb turned on. Since the single wire is connected to the input number 3, using the getADC command, I can see what is on this input. When I see nothing, 56,000. 5 to 6. If I speak in it, then the value changes to 1,500 or 23,000. The sensor reacts to the voice change. Using a trimmer on the board, you can achieve stable work of the sensor. The next sensor is a touch sensor. The touch sensor is connected to the input. In fact, it is a usual conductor. When I do not touch the conductor, the value is around 3,000. When I touch it, the value increases to 4, 6, 7, and so forth. Next sensor connected to the controller is the input number 6. It's RFID. When there is no tag on it, it shows the value none. When you attach a tag to it, it shows the number of this card. There can be any tag up to such small sizes. It clearly and always identically determines the value of the tag. With this program, you can check any sensor, how does the magnetic lock or the relay work, and so on. Thanks for your attention.